This is Calculus 2 class. We're gonna start improper integral. Improper integral is kind of different from what we did so far. Improper integral is about definite integral, but a little different. First, we're gonna define what the improper integral is. Then we have to understand different between two different type of improper integral. So one is in finite unbounded intervals. Second is infinity discontinuity. Third one is recognize when you given definite integral is improper or not, and they explain why. Then last one is we have to evaluate improper integrals using limit. So let's get started this improper integral. There are two types of. Let's just start with improper integral with infinite interval, guys. So look at this integration a to infinity fx dx. How gonna define this integration? Interval gonna be infinity, an infinity. What you did so far when you're using first fundamental theorem, our interval gonna be finite interval. So how gonna define this integration? We're gonna calculate, evaluate a and t f of dx first. Then we're gonna take limit t approach infinity. So this improper integral have a limit, so we have to check it out. This limit exists, which means convergent. This limit does not exist, which meaning is divergent. This limit is convergent, that improper integral converges. This limit divergent, this improper integral diverges. Let's have the first example. First example is 0 and infinity e to the negative x dx. The infinity interval 0 and infinity e to the negative x dx. How gonna define this improper integral? Gonna be a limit t approach to infinity. T gonna be move. Interval gonna be 0 and t, but t gonna move. So first we have calculated 0 and t to the negative x dx first. Then we're gonna take a limit of that value and we're gonna figure it out of improper integral. So first, this is definite integral. Find the antiderivative e to the negative x. That's gonna be negative e to the x. Then we're gonna evaluate this antiderivative 0 and 2. Plug in t first. Limit t approach to infinity negative e to the negative 2 minus positive e to the 0. E to the 0 is 1. E to the negative t gonna be 1 over e to the t. So we have limit x of t approach to infinity, negative 1 over e to the t plus 1. What happened, guys? T approach to infinity, et going to infinity. So 1 over et going to 0, guys. That should be going to 0 because et going to infinity. So this limit is 1. What is conclusion? We evaluate improper integral. Now we're gonna say integral 0 and infinity to the negative x dx converges to the 1. That improper integral has 1, meaning is they converge 1 because they have limit. Let's do one more example, guys. Let's do 0 and infinity, 1 over x squared plus 1 dx equation. So definition of improper integral is limit t approach to infinity, 0 and t gonna be moved, t is getting bigger, 1 over x squared plus 1 dx. Guys, remember antiderivative 1 over x squared plus 1, that's arctangent x. Let's calculate, let's evaluate antiderivative, arctangent t to 0, 0 and 2, so plug in there. So limit t approach to infinity, tangent t minus arctangent 0. So as you know, arctangent 0 is 0 because tangent 0 is 0. So that part is 0. So we have t approach to infinity, arctangent is t. So what is this value gonna be? Let's check it out, the tangent value. Tangent pi over 2 is infinity. They're going to infinity. Arctangent infinity meaning is pi over 2. So this limit is gonna be pi over 2. What do you mean by that? Now, we evaluate improper integral 0 and infinity 1 over x squared plus 1. That has limit to pi over 2. Now we're gonna say this improper integral converges to the pi over 2. Okay, there is another improper integral with infinite interval. We have a to the infinity. What if they have negative infinity and b? Exactly same way. We're gonna integrate t and b, then t gonna be going to the negative infinity. So this limit exists, that improper integral converges, this limit does not exist. Improper integral divergent. Let's have example. This time infinity interval is negative infinity to the b gonna be, guys. Look at this one. Negative infinity and 0. 1 over x squared plus 1 dx. How can they find this improper integral? Because they have infinity interval. So limit t approach negative infinity, t to the 0, 1 over x squared plus 1 dx. As you did with previous one, that's arctangent. So limit t approach negative infinity, arctangent x 0 and t. Plug in the 0 first, you plug in the t. So you have arctangent is 0. Then you have limit t approach negative infinity, negative arctangent. So t approach negative infinity, meaning is we have looking for arctangent negative infinity, then that's inverse of tangent. Let's find the tangent value. Tangent negative pi over 2 gonna be negative infinity, which meaning is arctangent negative infinity gonna be negative pi. So this limit gonna be negative pi over 2. So now, what are you gonna say this limit? So we're gonna say improper integral negative infinity and 0, 1 over x squared plus 1 dx converges pi over 2. So we have previous example is we're gonna be a to infinity. This example, we're gonna be negative infinity and b. What if we have to integrate over the negative infinity to positive infinity? You're gonna break down two improper integral. A value usually 0, you're gonna put it. So you're gonna separate two improper integral, negative infinity a fx dx plus a to infinity fx dx. That's evaluate this improper integral. We're gonna find integral negative infinity fx dx. But here's very important, both improper integral is converse, then integral negative infinity fx dx converse. One of them is not converse, which meaning is divergent. Then this improper integral is divergent. Let's have this example, guys. Negative infinity over infinity. So we're gonna integral negative infinity and infinity, 1 over x squared plus 1 dx. So we're gonna break it down two improper integral. First one is 0 and infinity, 1 over x squared plus 1 dx. Second is negative infinity, 0, 1 over x squared plus 1 dx. So first one is the definition is t approach to infinity, 0 and t, 1 over x squared plus 1 dx. Second is definition t equal negative infinity, t to 0, 1 over x squared plus 1 dx. But previous two examples, you already found this improper integral each, right? This one is t approaching infinity 0 and t 1 of x squared plus 1 dx gonna be pi over 2. That's why first one is pi over 2. Second is t approach negative infinity, t and 0, 1 of x squared plus 1 dx, pi over 2. So plus pi over 2, pi over 2, that's gonna be pi. So first improper integral, we have infinity interval. Now we're gonna do another improper integral right now. Let's do another type of improper integral with unbounded discontinuity. How do you know this is another type of improper integral? We have to find vertical asymptote of f of x. Simply say f of x says vertical asymptote x equal a. We cannot integrate a and b fx dx. So we cannot apply first fundamental theorem for this definite integral. So we have to define limit right there. X equal a is vertical asymptote. So we have find the integral t to the b fx dx. T approach the a from the right. So that's we're gonna define improper integral with unbounded discontinuity. Like we did in previous improper integral, this limit is converse, this improper integral converse, this limit is diverse, this improper integral divergent. Okay, let's have the example with this improper integral. Let's have example with unbounded discontinuity. Each way check improper integral with unbounded discontinuity. You're gonna check the vertical asymptote. Let's sketch a y equals square root x graph. Y equal 1 over square root x graph. I sketch it. This integral meaning is you're gonna find area below the curve 0 and 1. So can you see the vertical asymptote line right there? That's gonna be vertical asymptote x equals 0. 0 is lower limit. In that case, we cannot apply first fundamental theorem. We have to use definition of improper integral. So t approach 0 positive, integral t to 1, 1 over square root x dx. First, you find the antiderivative 1 over square root x. That's going to be 2 square root x plus c. Now we're going to evaluate this integral first. Limit t approach 0 positive, 2 square x and 1 and t. You plug in 1t, you have limit t approach 0 positive, 2 minus 2 square root t. So now t approach 0 positive, you have 2 minus 0, that's gonna be 2. Now what are you gonna say? This improper integral 0 and 1, 1 over square root x dx converts to the 2. Let's thinking about two different integral, guys. The first one is integral 0 and 1, 1 over square root x dx, which means this is improper integral because as you see y equals square root x, we're gonna find the area below the 0 and 1, x equals 0, that's the vertical asymptote. That's why that's the improper integral. But second one is the same function, 1 over square root x, but interval is different. Interval is 1 over 4. Interval 1 over 4, there is no vertical asymptote. So this is not improper integral. Which one is improper integral? Only first one. When you have improper integral, we did the previous one, we have to using definition of improper integral right there, guys. The improper integral gonna be 2. We did previous slides. How about the second integral? That's not an improper integral because there is no vertical asymptote x equals 0. So we're gonna do regular definite integral by using first fundamental theorem. What is antiderivative? That's gonna be 2 square root x, 1 and 4. You plug in the 4 first. That's gonna be 2 square root 2. That's 4. 2 square root 1, that's 2, That's 4 minus 2 is 2. I think you clearly understand when you're using improper integral. Improper integral, you see the vertical asymptote line boundary x equals 0. That's you're going to define the improper integral. Next one is another example right there, guys. So this time we're gonna do integrate -1 to 1 of x cubed dx. So this is a finite interval. Function is 1 of x cubed rational function. When you see rational function, we're gonna find the vertical asymptote. What is vertical asymptote? X equals 0. Let's sketch y equals x cubed. So y equals x cubed, I have sketched it. We want an area -1 and 2 under the curve. We find the area under the curve, y equals 1 over x cubed over -1 and 2. But what is there on the graph? You find x equals 0. That's the vertical asymptote line. So we're gonna say this integral is improper integral. 0 is between the -1 and 2. So that's you have to separate -1 and 0. Another one is 0 and 2, 1 over x cubed dx. Both of them are improper integral. Let's just try 0 and 2, 1 over x cubed dx first. This one gonna be limit t approach 0 positive integral t and 2 1 over x cubed dx. That's gonna be, we have to find the definite integral. We have to find the antiderivative first. That's integral x negative cubed dx. That's gonna be -1 over 2 1 over x squared. Then plug in back, you're gonna plug in the 2, you're gonna plug in the t. Then I'm taking out the -1.5, plug in the 2 first, 1 over 4, plug in t, t gonna be -1 over t squared. Now, we have find the limit of 1 over t squared, right? What happened? T approached 0 positive. Number is getting smaller, smaller. T square is going to 0, which meaning is 1 over t square getting bigger. That's going to infinity. So what are you going to say? This whole limit going to diverge, going to infinity. Now, you have two improper integral there. One of them is diverse. You don't have to check the other one.